Okay, thank you. So, grid layout is a thing, and we can now celebrate over a year of having grid layout in browsers. I think most people think it's pretty cool, and quite a few people have even built sites using it. The CSS working group we've already got a first public working draft of grid level 2. I've kind of given up trying to answer every single question I get by email because I get an awful lot of them about grid at this point. Instead, I try and write articles and talk on stage about the things that I see people are struggling with grid. And it's become very apparent that there are a few areas where people's issues with grid layout originate. And the first of those is sizing. People are very, very confused about how big things are and kind of how Flexbox and Grid distribute space. And the reason it's confusing is that we've spent years and years using layout methods that are very straightforward when it comes to working out how big things are. Because we've sized things using length units, which makes sense, pixels or ems, we understand what those things are. We've also particularly used percentages a lot, particularly in responsive design, but that's very straightforward math to work out actually what a percentage means in terms of your design. Those percentages don't look particularly pretty in our style sheets, but they are understandable. We know that if we don't get more than 100%, everything will be okay. And we got box sizing border box. And that made everything so much easier. We weren't having to kind of work out what our padding and so on was going to add to our sizing. And I think recently as well, we've also been using things like layout frameworks, or perhaps we're using some mix-ins in SAS to do the calculations for us. So we're not even having to get a calculator out and work out what those percentages should be. And we've got things like calc as well. And then we got Flexbox and Grid layout. And kind of one of the things that was said about these is, well, you don't have to be working out all these percentages anymore. But when we start to use Flexbox and Grid, sometimes things don't quite end up the size that we expect them. Things in our designs become bigger or smaller than we imagined. And the result of this is that people have started to create Flexbox-based grids which used percentages, just like their floated forebears. And with grids, the first thing most people try to do is to try and make a grid layout using percentages, going back to what they know works. They knew how to do percentages, keeping away from this slightly mysterious FR unit, which doesn't quite seem to share out space the way you think. So that's why this year a lot of my talks have been about how big that box is, just explaining the sizing constructs in Flexbox and Grid. Because I think understanding sizing is so, so important at the moment, because it will let you really sort of unlock the power of these technologies. So let's have a little look at how sizing works in Grid. And we'll learn quite a few useful things along the way. Now, actually, if you really want to dig into sizing, you have to do a fair amount of scrolling right down the CSS Grid spec. There's an awful lot of it. And if you want to get down to the really sort of depths of this, you need to go down to the bit which most web developers tend to ignore, and they think that bit's for browser engineers. I'm not a browser engineer, I'm going to ignore this stuff. The grid sizing algorithm. And it's in there that we enter the rabbit hole, and I'm not going to explain the grid sizing algorithm line by line today, you'll be very glad to know. Instead, I'm going to pick out some of the bits that I think are most useful when you're actually using grid. So the spec says that each grid track has specified minimum and maximum sizing functions, and they might be the same. So what is a sizing function? Well, we have three kinds of sizing. We've got fixed sizing, intrinsic sizing, or flexible. Now, fixed sizing is what we all know about. It's how we've been doing layouts for years. We've been sizing things as a length unit, say pixels or ems, or as a percentage. A percentage is a kind of fixed sizing because it resolves to a length. So then we have intrinsic sizing. Now, you're probably most familiar with the intrinsic sizing of auto, but we also have specific intrinsic sizing keywords of min content, max content, and fit content. So we'll have a look at auto first. Now, auto kind of means something special depending on what it's been used for. I think people often think auto means default. It doesn't really. It has a special meaning depending on the specification. But when used for grid track sizing, you can generally think of it as being big enough to fit the content. And we'll have a bit of a look at actually what auto really means. But if you've ever created a grid with auto-sized rows, you'll know that those rows expand, you put in some more text, and the row will just expand down. Now, something useful to know about auto and track sizing is that if you use auto for a track size, that will stretch by default, take up any extra space in the grid container, unlike any other sizing function. So where you'll tend to notice this is in column tracks. If you use auto here for the final column track, it stretches and takes up the remaining space in the inline direction. Though the actual size created by the auto track is what you see if you add justify content start to override that stretching behavior, which can make auto seem a bit mysterious because suddenly it takes up all this extra space that maybe you weren't expecting it to. So if you remember that the default for justify content is stretch and auto tracks will stretch by default, don't want that behavior, set justify content start on the container or target the individual item, and then it won't do that stretching. So that's auto. And we've then got these new sizing keywords. They're not only for grid, you can use them for sizing elsewhere, although they're not as well implemented just generally as they are in grid layout. But these keywords also form really important sizing concepts that's just useful to understand. So we've got min content. So you can use the keyword min content for track sizing. This will make the track as small as it can be without the content breaking out of the track. So in the case of a track containing text, the text will take all of the soft wrapping opportunities it can and kind of get as small, it'll become as wide as the longest word in that track. So here I've got 3 column tracks, all sized using min content. So now that track content is going to impact the track size. So we're not deciding how big the track will be, the content is making that decision for us. So we're going to end up with something like this. Now, if any item in that track has a width of some sort or contains something that has a fixed width, then the size will be dictated by the width. And as if it's text, the text will all wrap and really get as wide as the longest word. So that's min content. The opposite of that is max content. So if you use max content for track sizing, that means the track's going to get as big as it possibly can get. If it's got a string of text in it, the text is all going to unravel and get as long as it can. It's not going to do any soft wrapping at all. And that could cause overflows if that makes the track too wide to fit inside whatever space the grid container has. So here we've got 3 tracks all sized with max content. So again, the browser's looking at the content to work out the size of the track. So here we've got our first and second tracks there. They're stretching out to the maximum size of content. The second column track has an item with a width in it, so that's sort of just going to the width that it is, and then it's the content in the item above is what is defining the actual track width. And then we have fit content. And this is a really useful keyword because it acts just like max content, so the content tries to get as big as it can do, but you pass in a value. You pass in a value and you say, I do not want this track to get bigger than this value. So be like max content, get to that value, and then start doing your wrapping. So I've got 3 tracks here. The first 2 clamped at 10 M, the last one at 15 CH, which is roughly 15 characters. And we get something like this. So you can see there the first track, the content starts to wrap once it hits that maximum that I've set. The second track just has the letter E in it, and so that never gets any bigger. That's just going to its max content size. And then we've got an image in there, which is just sort of sizing down to fit in size the track. Now, those concepts, you can use those keywords to create tracks, just like I have there, but remember the concepts because they're important as we look at some more of the sizing sort of functionality. So then let's look at the FR unit. So this is how we can do our flexible sizing, and this has been designed for grid layout. You don't get an FR unit anywhere else. So a flex unit defining a flexible length, a portion of the space in the grid container. So if I define 3 tracks, 1 of 2FR and 2 of 1FR, the available space is going to be divided into 4 and shared out, 2 parts to track 1 and 1 part each to track 2 and 3. So you'll get something like that. Now when you see a demo like this, it looks like the FR unit shares out all of the space in the grid container evenly. So 12 tracks of 1FR should be 12 equal tracks, and it's not quite, as we'll see if we dig a bit deeper. So those are all the ways that we size things. They're the different sort of sizing functions. So now we can kind of figure out what the minimum and maximum size for each track might be. And we can actually look at this directly with a function that is used in grid layout, min-max. Now, min-max lets us set a minimum and a maximum size for a track. It lets us say, take it into our hands and say, well, I want to say what the minimum and the maximum is. So if we use min-max for a track, then the minimum size is your first value, then you have a comma, and it won't get smaller than that, and then you have your maximum size. So here, the minimum sizing function that we're going to use here is 100 pixels for one track and 10M for another. Now, if you use FR units or fit content, then the minimum size of that track is auto. Now, otherwise, you're using a length or a percentage, in which case the minimum sizing function is that length or a percentage resolved to that length. So then if we look at our maximum sizing, if you use min-max for your track, then the maximum size is the value after the comma, the second value you've passed in. So your track's not going to get larger than that maximum. So here I've got 400 pixels or 20M. If you use auto or fit content, then that should be treated as max content, unless you've passed a value to fit content, in which case that becomes the max. And obviously, if you've used a fixed sizing, well, it's going to be the same as the minimum sizing function. If you've said 100 pixels, then it's going to be 100 pixels. That's all you get. So that's kind of how we've got our minimum and maximum sizes for our tracks. So we should be able to work out how big all our tracks are. So the simplest case is when we have a fixed size for our track. So the minimum and maximum sizing functions are exactly the same. So here, if we've said the track is 200 pixels, then that's what you're going to get. Everything here is a fixed size. Nothing is flexible, nothing is intrinsically sized. So that's a very, very basic grid. We kind of understand how that works. And then we get to really what we've been doing for years. We're using fixed sizing for our columns, and then we're allowing the content to be auto-sized, so it just expands, and we put in some content and it stretches down. So that's pretty much as far as you can get with, say, a float-based layout. But with grid, well, I might want to use a flex sizing function. I want to use the FR unit to size my tracks and let the content define the row height, and that's a sort of fairly standard thing to do. So that this gets a little bit more interesting in terms of working this stuff out. Because I mentioned earlier that if you have a set of 1FR tracks, that doesn't necessarily mean they will be equal sized. Because if the track is sized with FR units, then it's as if we've used the sizing function min-max auto 1FR. The minimum size is auto. So grid gives the tracks an auto minimum and then shares out the remaining space in proportion. That means if you've got 3 1FR tracks, they're not necessarily going to be equal, because if there's a very long word or something in one of those tracks that means that that auto is bigger to start with, then there's less space to share out. So we might end up with something that looks like this. Those tracks are all still 1FR, but because we've got that very big unbreakable thing in one track, or that might be an image or something else that's got a width on it, then it's the available space after the auto sizing that is being shared out. And that's why the FR unit sometimes seems a bit mysterious. Why has that one track got much bigger? Well, it's because it's going from auto. If you really do want to share out equally all of the space in the grid container, then you can use min-max. If you say min-max 0, 1FR, then what happens is we just go from 0. So we're now saying none of these things have got a width. All of the space is up for grabs. Please share that out equally. Now, in the case of having a very long word in there, you're going to end up with something like this. You're going to end up with an overflow, which is why Grid is kind of doing this. It's a bit like a Flexbox and sharing out space from a flex basis. We tend to be trying to make things fit rather than causing overflows as default behavior. But if you want that to happen, that's absolutely fine. You can do that. Of course, grid items can span more than one track. And in that case, if there's enough room across the 2 tracks for the item, then they'll go back to looking like equal width columns. So in most cases, if you did have, say, a 12-column grid with 12 tracks, all 1 FR, and things were spanning over multiple tracks, then most of the time they would be pretty equal. It's when you see it not happen, then you think something very strange is happening, but that's why it's that auto minimum. And then we have, everyone's sort of favourite trick, this ability to add as many columns as will fit into the grid container by using repeat notation and the autofill and autofit keywords. And this sort of statement looks a little bit strange until you've looked at sizing, and hopefully it makes a bit more sense. Because what we're doing here is we're handing out a minimum size of 200 pixels. We don't want any columns that are smaller than 200 pixels. And then we're handing out a maximum of 1 FR. 1 FR distributes available space. So we're going to get as many 200 pixel columns as will fit, and then whatever space is left over gets distributed to the rest of the tracks. And so we can get these nice arrangements of boxes. And these would be responsive, so you get these gaps in your arrangement depending on how many fit on each line. And we can even pack them densely by setting autoflow to dense, which gives us a grid with a flexible number of flexible columns packed densely, and the browser just does this stuff for us with a few lines of CSS. And there's so many creative possibilities here. Once we get away from thinking just in 12-column grids all the time, what sort of patterns can we create if we move away from that and actually really take advantage of all of this sizing and the things that we can do, size things based by content, rather than sort of restricting them to fixed track sizes. But then there's something else that is very important about grid. It doesn't really matter which way up your grid is. So my original CSS Grid presentation, long before Grid shipped in browsers, when I was going around just talking about how Grid was going to work, I'd go through all of the different properties just as quick demos and show them to people. And I'd explain that we could define all 4 lines of a grid with the grid area property, and that the order of the lines was grid row start, grid column start, grid row end, grid column end. Now this is actually, if you think about it, the opposite of the way we declare lines in everything else in CSS. If you think about margins and padding, the shorthands there, the way that we're declaring these lines goes the other way round. So why is that going on? Is this just a CSS working group playing some sort of funny joke? And it's not. It's to do with the fact that in CSS, the values are moving away from this underlying assumption that content on the web maps to the physical dimensions of a screen, with the first word of a sentence being top left of the box that it's in, because of course it's only top left if you're in a horizontal writing mode and working in a left to right language like English. So the order of lines in grid area makes complete sense if you'd never really encountered how we do things already on the web, because we're setting the 2 start lines and then the 2 end lines. And what this means is if we change the writing mode of our document to a vertical one, the position of a block remains relative to the writing mode of the document rather than the shape of your screen. So in any writing system with a horizontal writing mode, and that's whether the text is left to right like English or right to left like Arabic, the inline dimension is along those rows of text from left to right or right to left. So the inline dimension is like a sentence. It's the way a sentence flows. And if the inline dimension is running horizontally, then the block dimension is running down the page top to bottom. So that's the order in which blocks lay out on your page, one after the other, say paragraphs. So you'll often hear mention of the inline or the block axis when you're working with grid and flexbox. So these are really useful to remember. If something's been aligned on the block axis and you're working in a horizontal writing mode, the block axis is the one that blocks layout on going down the page. So if we're working in a document with a vertical writing mode, then the inline dimension is going to be top to bottom, because that's the way that the sort of sentences flow in that writing mode, and the block dimension is going to run horizontally. So here's how this works in grid layout. In a horizontal writing mode, the inline axis is running horizontally and the block axis vertically. Now flex layout gets a bit more complicated, because obviously in flex we can set the flex direction of row or column. So in flexbox what we tend to do is refer to the main and the cross axis. So the main axis is the one dictated by flex direction. So you said flex direction row, that's going to be your main axis. And the cross axis runs across that, and so that's by default. If in English, if you've gone to row, that would be down the block axis. So when we're setting the start and end lines for grid area, all we know is that we've got start and end lines. We don't know or care about whether that's top, right, bottom, or left. So if this is my 3-column 2-row grid and I want a grid area in a horizontal left to right writing mode to cover the first 2 column, the first 2 row tracks, so it's going to sort of end up here, we can see the column and row start and end lines, and how in the grid area property we set both starts, then both ends. Now if we were using a language like Arabic or just using that writing mode running right to left, it's exactly the same, but start is now going to be on the right. So that's the column and row start and end lines, and the grid area property, we're setting both starts and both ends, and it's going to look like that. And if we end up working with a writing mode that has our content running vertically, we have this. So the grid is working exactly the same way no matter which way up it is. The line-based positioning works in exactly the same way, whichever way up it is. And you'll find the Firefox Grid Inspector really useful if you want to play around with this stuff. So these are screenshots from Firefox. If you are using grid layout and you don't normally use Firefox as a development browser, very, very useful. Firefox are doing wonderful work with their dev tools. It's really worth grabbing if you're wanting to sort of play around with this stuff. So we can actually visualize where our line numbers are and keep ourselves in track. So that's just a sort of useful tip. You know, do have a look at the Firefox dev tools for grid. So once you know a bit about writing modes, then hopefully that will help remove some of the confusion around alignment and grid layout. Because alignment cares about the writing mode of the document too. And again, we don't think about left and right, top and bottom. We think about start and end in each dimension. And in grid, we've got 2 different things that we might want to align. We've got the tracks themselves, assuming there's extra space in the grid container that we might want to share out. And then we've got the items. So you've put something into a grid area. How is that aligned in the area? And alignment is defined in the box alignment specification. So remember that great big long grid layout spec? That doesn't include any alignment stuff. That's all in box alignment because it's shared with things like Flexbox. So let's look at aligning tracks first. So I've got a grid container which contains some fixed size tracks. And so the amount of space to lay out the tracks is smaller than the actual size of the container, which gives me some spare space to play with. So just like you can't align flex items if you've got no spare space, it's the same with grid. If you want to align your tracks, you need some space to play with. So by default, tracks are aligned to start in both rows and columns. So they'd be like this if we were working in English, up in the corner, and the white space there is our spare space. So the content properties deal with free space. What do we want to do with that leftover space? Align content and justify content. So align content works in the block dimension. If you are aligning, you are working in the block dimension. And justify content works in the inline dimension. So if you are wanting to align in the inline dimension, use justify. So I want all of my tracks to move to the end of the grid in the inline dimension. So along the rows, I use justify content end. So I'm going to the end line of the grid. So what this means is our free space is now placed before the tracks. If I want them in the center, in the block dimension, align content center. Our free space is now placed below and above them. So what we're doing here is distributing space. We decide where we want our tracks, and therefore what happens with the leftover space, which is really just like in Flexbox. We can use the keywords space between, space around, or space evenly. And again, you'll have used these if you've used Flexbox, so we can use those with grid tracks too. So here we're doing justify content space between on the inline axis and align content space around on the block axis. So our free space is being divided up and shared out. Now note, this will make our gaps bigger. If we've used a grid gap, it's going to make the gap bigger. But also, any item that crosses that gap is going to have to absorb the extra space too. So here I've got a large item which spans over 2 columns and 2 rows. And here's where they're aligned to start. And with space around the block dimension and space between inline, that block gets a lot bigger because it's absorbing all the extra space. So if you are going to do that sort of thing and you're going to sort of space everything out, you need to make sure obviously that the things that are in those areas can cope with being stretched out too. So you might have guessed, well, all of this works in exactly the same way if we use a different writing mode. Start in the inline direction is always where a sentence starts. Start in the block dimension will go down the blocks of the page. So we can do things like this. If you look at the code, all the code for this talk is online. If you look at the code, you'll see the use of block size instead of height and inline size instead of width. Now, these are new logical properties. CSS in general is moving away from being tied to physical dimensions. We're kind of getting aliases for all of those physical things, making sort of logical versions of them. I don't have time in this talk to go into those, but I did write a long post on Smashing Magazine, which has a whole load of little examples which work in Firefox. Firefox is the only browser to have implemented all of these at the moment. If you go, you can play with the code pens and sort of see how all these logical properties and values work. And it sort of takes a little bit to get your head around it. But once you have got your head around it, you find it very hard to think in the physical way. At this point, I'd much rather be working with logical properties. So that was sort of aligning our tracks if we've got free space in the grid container, which is probably a less likely scenario than this scenario, which is where we actually just want to align the things inside a grid area. So here we have align items and justify items, which basically just set the align self and justify self properties as a group. So again, if you are aligning, you are on the block dimension, and if you are justifying, you are in the inline dimension. The default for align items and justify items is stretch, unless the item has an intrinsic aspect ratio. For example, an image. We don't stretch your images by default because generally people don't want that to happen. So in that case, it will be start. So that means that generally content stretches over the area, which is why if you're using grid, and the same with Flexbox, you get full height columns. If things have got a background image, it will stretch right the way to the bottom, and you get this sort of full height column effect. That's the stretching going on. And of course, you can change that alignment. So here I'm saying justify items end. So all of the items are going to the end of their area. And saying align items start. So now I'm on the block axis and they're going to the start. Once again, the Firefox Grid Inspector really useful because you can see where the area is and therefore where the item is ending up going. So you can see the areas are still exactly the same. It's just the alignment of the thing inside it that has changed. So what align items and justify items is doing is setting the align and justify self properties on individual items. So for instance, perhaps we do want that image to stretch right over the area it's in. So we could do that. We could go for that image and say align self stretch, justify self stretch. And it would then stretch all over the space of that grid area. So you can play around with these things. So once you've got a grid set up, you can then play with alignment, and actually, a grid can end up not looking very grid-like at all. You've got these sort of creative possibilities in playing around with your grid. So this is all really neat. We've got all this new stuff. But I'm going to kind of finish up by talking about the third thing that I am saying a lot this year. When I demo all of this stuff, typically someone will ask something which is essentially, can I have a magical polyfill which will fix Grid in older browsers? And the answer is no. No, you can't. Here's why. We've got Grid support in all of these browsers now. But what can I use is really bad at showing is the unupgradables. The people stuck on old browsers because their device does not support an upgrade. And other than those people in companies who refuse to upgrade from an old version of IE, increasingly those browsers are mobile browsers in non-Western countries running on slower, older hardware on expensive data plans. Why would you force a bunch of JavaScript onto those devices? The things that Grid is doing, they perform incredibly well. I've run a whole bunch of tests on like massive Grid layouts to see if I can find places that don't perform well. Grid performs incredibly well, and you don't need a lot of code to do it. What does not perform well is JavaScript attempting to do what Grid is doing. You know, just try and do equal height columns with JavaScript on a decent amount of content, and you will see how janky that gets. You know, this isn't an anti-JavaScript thing, it's just a fact. You know, it's not a good way to do layout. And by being really lightweight in terms of how much CSS you need, in addition to sort of not needing all the extra elements, wrapper elements around each row, Grid can actually help you make a better experience for those people who don't support Grid. You know, if you want to create a 12-column flexible Grid layout with all boxes in a row as tall as each other, that's 4 lines of code plus a line of code for every item you want to position. You can afford for those few lines of code to be downloaded by a browser that won't parse them due to not supporting Grid. And we don't need to leave older browsers with no layout. You can create fallbacks these days just using CSS. Because, surprisingly, new CSS and the CSS working group, like we know about old CSS. So new CSS specs are designed to kind of build on top of what we've already got. So you can build simpler yet still completely usable layouts for your old browsers and your non-supporting browsers. Just as you build a layout tailored to small screen devices using media queries, you can build a layout tailored to your non-Grid supporting browsers by using feature queries. It's the same thing, you know, whether we're detecting features of the device or whether we're detecting what's supported by the browser. That lets us create good experiences for users, whether they're on a very small screen or a massive screen or a low-powered phone or, you know, a really old browser. These things are the same. What features does this device have? What features does this browser have? So if we consider what happens if our user has almost nothing, we structure our content well. If that content just loads in normal flow layout, one thing after the other, that's actually going to be pretty good for a lot of devices, particularly small screen devices. Certainly better than a horrible janky experience of trying to load in a load of JavaScript to get them to get what people on a really fancy iPhone are seeing. Maybe that small device does have CSS Grid. So I'm going to add a little header. This is one of my favorite Grid tricks. I'm using generated content here to add a line either side of a heading, something that was just horrendous to do in the past. So this, you know, just looks nice in a Grid supporting browser. Now, with just doing the line, you don't normally see that showing up in a non-Grid supporting browser, but say if you threw in a little icon either side, that would actually show up in the non-Grid browser and look weird because it might support the generated content but not the positioning of it. So maybe we want to make sure that we don't show up our Grid stuff in a non-Grid browser. So here I can use a feature query. So what I'm doing is I'm checking with the browser. I'm saying, hey browser, do you support display Grid? The browser says, yes, I do. And say, well, here you go, have this CSS. You don't really need to worry about browsers reading the Grid CSS if they don't support Grid, because the way browsers work is they come across some CSS they don't understand, they just go, don't do anything with it, just throw it away. But it's the things that would be understood by non-Grid browsers and Grid browsers but only make sense in a Grid context. They're the ones that you probably want to wrap in a feature query. So we have our mobile with no Grid, mobile with Grid. Oh, and by the way, the image there is set round just by using the well-supported border radius. Don't forget that old CSS still exists and is useful. You don't need to use something fancy for every effect. So as we get a bit wider, I'm going to take that image and do something neat with it. I'm going to float it left and cause the text to curve round by using shape outside margin box. That's CSS shapes. So we get this, we get sort of curving round the shape. That's pretty nice. It doesn't matter about browsers that don't support CSS shapes because, as I say, they just ignore it. They don't understand what that property is, and you'll get that. Because it's applied to a float, nice bit of backwards compatibility there, you just get a normal floated effect with the text all squared off. By the way, that's actually Firefox, which doesn't support shapes, but will next week when Firefox 63 ships, also with a very nice shapes inspector. So once that feature ships in Firefox, those users get the nice effect. And it's like, oh, this looks better. You've not shipped any new code. It was there waiting for them. So we start to get wider. Well, that text is now getting too big. So I think I'm going to break that into 2 columns. Now, I'm co-editor of the multi-column layout spec, which means I have to have some multi-col in all of my talks. So I'm going to do that here. I'm going to use multi-col. Multi-col is really well supported for sort of basic stuff. So let's do column width 15M. So we'll only get 2 columns when there's enough space to be able to support that. Now, the problem with multi-col is if you're on a very short screen, what you don't want to do is end up scrolling up and down that content. That's a terrible reading experience on the web. So let's use a vertical media query and check for height. So we'll only get 2 columns. We've got enough height for the sort of content I imagine to have in there. We tend to think about screen width a lot on the web and not so much about height, but it can sometimes be quite useful to do things based on how much height someone's got, on their device. So we've got this. If we've got enough space and we get 2 15M columns, we don't need a width media query. And so then to finish off my article component, I'd like to do something with those cards at the bottom. So we've got some more room for them to display more than one in a row. I'd like to order those boxes into a little grid and line that up with my columns. I've only got 2 of them as well. That would be nice. So I'm setting resources to max width 60M and then using the grid autofill functionality, I'm filling that container with columns which are a minimum of 15M. So we get 1 column if we're under 15M. If we've got enough room for 2, they'll line up under my multi-col elements. And then if we've got 3, we'll have 3 sort of lined up equally. Now, of course, this is only going to work if you've got grid. So what am I going to do for my non-grid browsers? I think it might all be a bit wide and spread out if I just leave it alone. If you look at your browser stats and you've hardly got anyone not using grid, you might just leave it. It's still readable. But let's try some other layout method. Let's try display inline block. So we can use inline block. The only thing we need to put in our feature query is a width override, because obviously grid is going to be, if you have grid, then the width is going to be interpreted and things will become a sort of width of that grid track, which you don't want. So we're just setting our width back to auto. In production, what I tend to find is that inside my feature queries is a stack of things with their width being reset to auto, because everything else is just overwritten. If a display inline block item becomes a grid item, the display inline blockiness just gets thrown away. So we end up with this. So inline block does mean that our cards still run left to right, but you kind of get these gaps underneath the cards. An alternative, if it would be okay for the cards to display down the columns, is that you could use multi-col, just like in the first section. So here we'd use multi-col. We don't need to override the multi-col because once it becomes a grid item, the column properties again get thrown away. And so that's another option. Now, the reason I'm showing you this isn't so much to show you how to do fallbacks with grid. There's a few tips in there. It's because I want you to see how little you actually need to do to create fallbacks for grid. If you think about this stuff component by component as you build your site, it doesn't take a lot of extra work. What you don't want to do is wait until you've built your entire website or application and then think, right, oh yeah, old browsers. That's just a pain. If you think about these fallbacks, component by component, it's not a lot of extra work, and it just all sort of builds itself up. But the key thing is, we can create components that work in all of these cases, from small to large screens, from browsers without grid to grid, without needing to ask people on the most limited of devices to download a whole bunch of JavaScript to try and get the same look as someone on the high-powered device. We like to talk a lot about performance. But the thing is, before you start to worry about, is this technique performant, think about, do I actually need to use it at all? Because often we're making things worse for the very people that we claim to be trying to support by making things look the same. So we need to reframe the discussions you have around browser and device support with clients and colleagues. It should never be, how do we make this look the same, but how do we give a good experience to everyone? Don't worry about making their experience the same. Worry about making their experience good. Because we're in a better position now to provide great experiences to everyone, far better than we've ever been. So don't let lack of support for new CSS sort of hold you back from realizing amazing experiences, trying out new patterns, trying out new ways to solve problems. But likewise, don't let all the new shiny mean that you forget about the people who don't yet have it. It's become a bit of a trite thing to say from conference stages that the web is for everyone, but I truly believe that. I've never been here to build shiny toys for rich people. And I think even the way that the web has been used for some not great things recently, I still believe in the power of this medium to educate people, to share messages, to change lives. And I think we start by creating things that work for everybody to do that. So thank you very much for listening. All of my code and examples can be found at that URL. Thank you.
Thank you, Rachel, for those great insights into CSS Grid. And are there any questions? She's not biting, I'm not biting. Are there questions?
I will be around all day. People can also come and ask me things.
Okay, so let's enjoy the coffee. There's a break, I think, until, what time is it right now? I think it's until 2:30, the break. So see you then.
Thank you.